Okay, so let's look at this problem. We have triangle ABC. So let's draw a triangle ABC and make sure it's an acute triangle. And we have that AC is greater than AB. So A, B, C. AC is strictly greater than AB. We want to show that if that's true, then angle B is greater than angle C. It's kind of like the reverse, it's the converse of the last problem, where we assumed that if the angles were greater, then the side has to be greater. So, this is an excellent example of what we can call proof by cases. So, this proof by cases technique is just stating all possibilities or all outcomes that we can think of. So, like, for example, case 1. Case 1. Assume that angle B is strictly greater than angle C. Based on our results from the previous problem, AC must be greater than AB. That is all the work we did in the previous problem. We assumed angle B was greater than angle C, just like we're doing now. Then that implies AC is greater than AB. That is something we absolutely know is true. And when we're listing these cases, we're basically saying each case is going to be like a different scenario. And each scenario is like a different possibility or a possibility of the outcomes of these angles. So one possibility is that, well, these angles are greater, and if they are greater, it automatically implies that that's true. So, what is another possibility? Well, that's case 2. What if angle B is equal to angle C? What if they were the same angle? What if they're congruent? Well, then triangle ABC is isosceles. And AC would have to be equal to AB because it's an isosceles triangle. So that's the situation that would happen if the angles were the same. So since if the angles are the same, then the side lengths are the same, but we said that AC had to be greater than AB, therefore case 2 cannot be a possible scenario for the proof, basically. So the third case 3, well, the only other possible scenario we have is that angle C is greater than angle B. Well, what happens if that's true? Well, based on the previous result, or based on, I should say, the previous problem, we would have that A B is greater than AC. That's just, imagine if we did this problem, except everywhere I wrote B, I instead wrote C, and everywhere I wrote a C, I wrote a B. I just flipped the variables up, basically. We would still get the same result, that this side AB is greater than AC. So that's the third situation. Now we have listed all possible outcomes of the angles. We have that what if the angles are equal? Well, then the sides are equal, which breaks our condition that the side AC is greater than AB. What if angle C was less than angle B? Well, then based on the previous problem, AB would have to be greater than AC, which breaks the result of our condition. So, since case 1 is the only scenario that fulfills our condition that AC is greater than AB, cases 2 and 3 are not impossible, but do not work. Therefore, angle B has to be strictly greater than angle C. Since case 1 is the only possible scenario that works if we assume that AC is greater than AB. This is the only logical situation we can have. Again, if the angles were equal, then the sides would be equal. If angle C was less than angle B, then we would have that AB is greater than AC. But since we're assuming that AC is greater than AB, that can't be true. So this can't be true. This can't be true. We are just left with case 1, where this was our outcome or our assumption. And that is the gist of proof by cases. List every scenario and figure out which one is the true one.